Alright, I just talked for a while only to discover that OBS had stopped recording. I'm pretty sure this is where it left off. Okay. So, yeah, you would think that doing lectures at home would be really, really easy. When you add in things like transcoding and times when some component or other blows up and you have to start over again, it becomes more time consuming. Alright. So if you use small convolution filters, your network won't narrow quickly, right? So it will involve a lot of computation, and because you'll have more weights and units than you need, you might still overfit, right? So what do I mean by will not narrow quickly? Oh, the tragedy of how far I've had to go back. What I mean is, if you have a 64 by 64 by 3 color image, excuse me, that's fairly big, right? If you want to feed that into 12 convolutions that are each 4 by 4, right? How big is your output? Cat? Well, your output is going to be 64 minus 4 minus 1 to a side, or 63 by 63. Each feature map is going to be 64 or 63. 1. Ha ha! I can do math. 61 by 61 by 12 for the number of filters, right? So 61 by 61 and 12 of them. That's a lot, right? One unit, one layer is 64 by 64 by 3 units, and then the next one is 61 by 61 by 12 units. That didn't decrease by much, right? And if we have possibly a lot more capacity than we need, right? And if we keep doing layers like this, the size of each layer is going to narrow very slowly, right? And we're going to find out that we very quickly have to do a lot of computation and possibly take up a lot of memory and might overfit. Well, fortunately, we have ways to reduce the size of a layer. We have ways to reduce the size of a layer. Kitty has decided it's feeding time. So we reduce a layer by subsampling it. Basically, by having some way to only pick some of the values out of a layer or combine a set of values into a single value. There are many, many different variants, right? People can publish by coming up with a good new variant. Max pooling is, I think, one of the original-ish ones from Linnet, and it's still very common. When you max pool, you define a little region, like 2 by 2, and then you replace all of the values in there with just the max value in a little 1 by 1, right? So you dramatically shrink the size of an image plane by doing that. Blah. So here, again, borrowed from our friend Wikipedia user Apex34, God bless you, sir. Flight of Angels, sing thee to thy rest. We have a really excellent little illustration of max pooling, right? Here, our subsampling, our max pooling filter, is size 2 by 2, and we are applying it to this region and picking the maximum value, which is 6, and then we're applying it to this region and picking the maximum value, which is 8, and so on, to reduce our 4 by 4 equals 16 size input to a 2 by 2 equals 4 output, right? Subsampling allows us to squirt a cat with a spray bottle and rapidly reduce the size of an image plane, right? So on the plus side, subsampling dramatically reduces the size of your image plane. Again, I'm sorry to use just like 5 different words to mean the same thing. Or filter map, right? Your input, right? Which dramatically speeds up your computation. And here is that somewhat abused phrase again. Subsampling, because it is throwing away information, acts as a regularizer, right? It makes it much harder for our networks to overfit because when you take a 16 input plane and squish it down to a 4 input plane, you, kind of like dropout, throw out a bunch of information and limit the number of parameters in the following planes, right? Bleh. More importantly, I think you throw out information, right? And that makes it harder to overfit. However, it also throws away a lot of information. This means that it can slow down training, or more precisely, learning. And it might even limit your ultimate performance, right? Because you might throw away information that you need, okay? The difference between pixels A and C in a 4x4 patch might actually be important to the rule, and if you throw away 3/4 of those pixels by subsampling, you lose that information, okay? So like so many things, it is a trade-off, okay? In particular, I suspect, and I have nothing but my own intuition to point to here, that this problem, the throwing away necessary information problem, is only likely to get you in the smaller, later layers, I suspect. Whereas larger, earlier layers, you're probably safer, okay? But, like so many things, you're just going to have to try an experiment. You're going to have to try a large network, right? See if it takes forever to compute a forward pass. See if you overfit badly. And then if you do, you can start using subsampling. I think a lot of the examples that I've seen, a lot of the handful of examples that I've seen, subsample at every layer they perform a convolution, but you don't have to. One thing you might try is only subsampling on some layers, and in particularly, preferentially subsampling on the lower, larger layers. Okay? But, again, you are just going to have to keep an eye on all of your various performance metrics and try different values and see what gives you the best result. Also, I would like to point out that I'm kind of using two different notations for speed here. When I say speed up computation, I am more talking about wall clock time, right? I am more talking about making an individual epoch go faster, right? Take less time. When I'm talking about slowing down training, I'm kind of more talking about requiring more epochs. Requiring more epochs, right? Needing more passes through the training data to adequately train, right? If subsampling makes this one decrease but this one increase, right, you would have to see how much it is speeding up the wall clock time versus how many more epochs of training you need, right, to see if it's actually worth it, right? That would be another one of those metrics and trade-offs to keep an eye on. All right, so subsampling in TensorFlow is pretty easy. It's just a layer. We put it right here, right? So max pool is one subsampler. It's the one we've been talking about. There absolutely are other ones that you could experiment with. Yep, here it is size 2x2, so it's that little 2x2 grid. Okay. And notice that I put it after the activation. In general, you could do it in either order, right? Because, well, okay, in general, you could put it before or after the activation, kind of. Yeah, I'm getting ahead of myself. All right, step backwards. I put it after the activation. That is generally the correct place to put it, right? In principle, you wouldn't have to, because for a bunch of x's, right, so f for activation, right, f is our activation, the maximum of those x's is the same as the maximum of the function applied to those x's, right? I said in general, right? This is true if f has a particular property, right, that most but not all of our activation functions have. Pause for a minute. Can you think of what property I'm talking about that most but not all of our activations have. It is monotonicity. Why did you minimize whatever you didn't stop recording good enough? Right? Which means always increasing or always decreasing. Right? If the function is always increasing, right, then for any two values a and b, f of a will always be greater than f of b if and only if a is greater than b, if, right, f is always increasing, right? And notice I didn't say how much greater, right? That would depend on f, but if we know that f is always increasing, and we know that a is greater than b, then we know that f of a has to be greater than f of b, and so for a monotonic function, these are interchangeable. Now, question the second, who can remember which function we talked about isn't monotonic? That's right, it's swish. For swish, technically, mathematically speaking, you would have to make sure that you got the order of these operations right, because for swish, f of max of x is not always max of f of x, because it actually dips down right here. It's not always increasing. Now, I say that because I'm just kind of trying to make an issue of the fact that swish is monotonic, and that was sort of, for some theory, a big deal. In practice, it probably doesn't matter. In practice, I bet you that if you flip the order of these layers, not much would happen, right? And that's kind of the reason why I didn't say that one is technically correct, because probably you could swap them. You'd be learning a different computation effectively, but it would probably also still probably work, right? And that's one of the joys of neural nets, is that you can do things wrong, and they sometimes still work. If you're bored by all of that conversation, then just put max pool after the activation. I haven't tried that. I don't know that it would work. I bet that it would. Okay. Put a video break here.